Shall I introduce you, Owen? Okay, good to see a good turnout this evening, especially given the good weather that we have. For anybody who doesn't know, my name is Sean Murphy. I'm one of the now two organisers. The other one is just running out the door there of the GTUG. Brian Farrell has kind of stepped back for a number of reasons, so it's only myself and Owen that are doing it. For anybody who doesn't know, I work at UCD. I'm not actually a Googler. Owen works in Trinity, so this is not a Google propaganda story, although there's a fair bit of Google stuff going on, obviously. So the focus today is security. This is one of the first ones that we've had like a pretty strong security, or a pretty strong focus on a particular team, and first one we've had a security focus. So we're lucky to have two great guys talking tonight. Fabio from OWASP, and I think his own company, Cubics, is going to talk first on the security risk for web apps. And then Martin Mitchell is going to talk about some stuff around the ethical hacking space. So there's kind of interesting contrast between the two different talks. A couple of announcements at the end, and then we're going for a pint. The session is being recorded. For anybody who doesn't know that, if you have any problem with that, I'm afraid the only solution is leave. Or you can hide your face, I suppose. We will publish them on the YouTube channel. Eventually, we're a little bit behind with them, but we'll get them up there eventually. Communications, if anyone wants to do any tweeting, hashtag Dublin GTUG. The resources that we have are on our lightweight dublingtugs.org page. So I think that's pretty much it. So I'll just hand it over to Fabio Cirillo to talk about the biggest security threats to web apps. Okay, very good. Hello, everyone. Thanks for coming. I know it's beautiful outside, so I really appreciate your presence here. What we're going to talk today is about the OWASP top 10. I will give a kind of a bit of introduction about the OWASP, what is OWASP, and kind of what's our goal. I'm involved in different organizations. I set up my own business kind of a few months ago, but I'm mainly focused in application security, helping OWASP in different kind of various activities. I am the chapter leader here in Ireland. We organize chapter meetings. The next one is this Friday here, actually. I'm going to talk briefly about that later. Also, we organize conferences, etc., and it's all around application security. So, what is OWASP? How many here, besides the people I know, how many know OWASP? Okay, quite a few. Like the mission of OWASP is all around kind of raising awareness about application security. And there are different tools and processes, and unfortunately, I don't have the time to go through all of them. What I'm going to do tonight is kind of give you a brief introduction about the top 10, what are kind of the top 10 risks in application security. But then you could go to the wiki, you could go to the different mailing lists and ask questions about it. If you're interested in the topic, there are tons of information available. So why bother with application security? In your opinion, like, why do you think it is important? Like, the most obvious is, well, you could say, if I build kind of secure code, it's better quality, so my employer will be happy. But also there are kind of regulations and compliance that now are enforcing application security. For example, PCI. I don't know if you heard about PCI, the payment card industry. Well, one of the mandates there is to not only kind of build secure code, but also review that it's secure. Okay, and OWASP has plenty of tools on that topic. Well, also there is the fact of users, that if you have users who are
giving their details. You need to kind of guarantee them that you're treating them securely. But the most important aspect of it is that it all comes down to risk, okay? And what I mean by risk, I know if you're able to look at this slide, I'm going to try to explain it very quickly. You have trade agents, okay? Trade agents are the users of your applications, okay? And those users will kind of come through and kind of start using your application. And this, for example, say you have a web form, okay? And that web form is not performing input validation. Do you know what input validation is? Yes? No? Okay. Say you have a web form that's not performing input validation, okay? So someone could go and start, sending malicious input to your application. That represents, say, a weakness, okay? And the fact that you are not performing input validation is kind of a missing control. Say your kind of application is vulnerable to SQL injection. SQL injection, anyone heard about SQL injection? Sony. Sony became famous for SQL injection. It's kind of it's kind of their pseudonym now. But like once you have an application that is vulnerable to SQL injection, you will be able to get to the technical bits of the application. You will be able to access sensitive information that you shouldn't have access to, for example, customer details, financial transactions, etc. But the most important bit is about the business impact, because you're talking about, and again, like for example, Sony had a big issue after the incident on how to solve it and the cost of solving that issue. So you're not talking about, okay, protecting the application just, as a nice thing to have, but you are also protecting your users. Here, like, this is kind of the OWASP risk rating methodology. I'm not going to kind of explain it in detail here, but there is kind of a very nice wiki page that explains all about it. Basically, based on the attack vector, the weakness prevalence, weakness detectability, and the technical impact, you could calculate the risk, okay? You could calculate the risk of each one of those top 10 that I'm going to explain you in a sec. So based on that risk methodology and different kind of bodies and companies that are focused in application security, we come up with the top 10. The top 10, like, does it sound familiar? Do you know the top 10? Okay, like, there are various things that we're going to cover. I'm going to explain for each one what's the actual risk, a scenario or an example, and then ways to prevent each one of those, okay? And then we'll have a QA. So injection, okay? Injection is all about, it's kind of making an application kind of do something that it wasn't planned to do. So for example, you could say, well, I would like this record, but also would like all these records as well. And there are various things or various ways of doing it. And there are kind of different locations where this could happen. You could have SQL injection, which is very common. Then you could have kind of an operating system injection, LDAP, XPath. There are different flavors. The main problem, and this is quite surprising because the top 10, it's kind of from 2010, okay? So all these issues were kind of identified or highlighted in 2010. We are in 2012, and still all the latest reports show SQL injection as the most kind of, kind of the vulnerability most present in the majority of web applications. So, like, people are kind of fighting against it, but not enough. So, like, the typical impact is usually severe. Like, as I was saying, you could have access to all the records. You could delete tables. You could actually do terrible harm to the company that's vulnerable to SQL injection. So typical scenario, you have a hacker there, and it will kind of send an HTTP request with kind of this format here. It's very easy to identify if an application is vulnerable to SQL injection or not. You just put kind of some text like that, okay, a string like that, and it will, if it just displays an error or says something about the SQL statement, probably it's vulnerable to SQL injection. So you need to work out, okay, what's the best way to attack the application? But it shouldn't, like if you put something like that to an application, if you have input validation in place and output encoding, nothing should happen. But in this case, the guy sent that request, the request is processed, and then you have that SQL query, so the application send that to the backend database, and this is what happens. In the background, you have a select SQL statement that will append that or 1 equals 1. And you know what happens when the whole statement becomes true, okay? So the database will just send all the results from that table, and nothing will happen. The application will process it and will send it back as an HTTP response to the user. So it is very obvious. Once you see it, you realize that it's very obvious, and it's something that you could solve kind of quite easily. I'm not going to get into much detail, but I will give you some kind of guidelines here. One of the recommendations is to avoid the interpreter entirely. So you could say, well, I will use kind of prepare statements or store procedures. So like you will have pieces of the statement that are code and pieces of information that are data, and they are clearly defined. You could encode all user input before passing it to the interpreter. So if there is kind of some malicious string, you will just get rid of it before it reaches the application. And then performing whitelist input validation. Do you know the concept of whitelisting? Well, whitelisting is all about, you know, setting up or having a list of things that are allowed in your application, and everything else is rejected. So, for example, you could have kind of you know the typical kind of syntax that you use for JavaScript. You could say, well, I will not allow that kind of characters in any input form. I will only allow text. And then, well, the thing is, you could also have kind of consideration when configuring or hardening your database. You don't need a user with a high-level privilege kind of accessing your application if you only need kind of that user to read some records. As reference, I would like to kind of talk about very briefly about the prevention cheat sheets that are available in the OWASP website. Like this is kind of a rough list that lists only kind of 3 or 4 recommendations. If you want the full picture, you could go to that URL address, that these slides are going to be available later on, and you could look at ways on how to deal with SQL injection. Cross-site scripting. Anyone heard of cross-site scripting? Okay. Well, cross-site scripting is kind of all about sending. It usually happens with JavaScript. If you accept JavaScript in your application and you parse it in your application, so there are three types. One is called store cross-site scripting. The other one is reflected cross-site scripting, and the other one is DOM kind of cross-site scripting. But I will not go into that today. So, like store cross-site scripting is where you have, say, a profile in your web application, and that profile is stored in a database. So you're able to say, instead of putting the address of your own, you just put some JavaScript and click save, and the application saves it. And then when you call your profile, that JavaScript is run as part of the code, okay? Reflected is the example where you have, for example, a search form, and that search form, if you put some piece of JavaScript and click search, it will actually execute the JavaScript. So it's kind of parsing the query as part of code. And like the typical impact is, obviously, like the most sensitive bit here is getting kind of someone stealing your user session, that you don't want that. Also sensitive data, redirecting users to, say, a malware or phishing site. That's very easy to do with phishing. And then the most severe is it's kind of install a cross-scripting proxy that will kind of allow users to observe what you're doing. Okay, so this is kind of a very quick example. Again, we have the hacker here that sets the traps with the profile. So the attacker will put some piece of code there that will get the, say, anyone who visits his profile will like JavaScript will run that will get the details of the user and send the session ID to that particular attacker. So how to avoid this? How to avoid cross-scripting? Well, the easiest one is to eliminate the flaw. So don't include user-supplied input in the output. That's a kind of a strong statement, and sometimes you need those users, you know, sending details to your application. So ways to say how to defend against this flaw. It's like output encoding all user input. And here I'm going to mention briefly ISAPI. ISAPI is kind of an enterprise security API that it's open, it's free, it's kind of developed by a whole bunch of developers across the world, and it's kind of part of OWASP. Kind of was revised by the National Security Agency. So it kind of has the seal of approval. It is very good, and it will help you to protect most of the top 10 issues. So I will highly recommend you to look at ISAPI on the wiki. Again, part of the recommendations is perform input validation as well, the whitelisting of all user input. And for large chunks of user-supplied HTML, for example, you have a forum, and you need, you know, people like, for example, boards.ie, you have loads of kind of text that you could submit to the application. If you need to submit kind of entire piece of text that could include code to some extent, you could use what's called the anti-SAMI. It's part of, I don't know if you know SAMI. Do you know SAMI? Well, SAMI was very famous a few years ago when he found a problem with MySpace, and he executed a worm that he became kind of friend to more than 1 million people, and then he was prosecuted and all that. So that's why we call it the OWASP anti-SAMI. And like it's something that will help you to protect big chunks of information and make it safe. And the third one is broken authentication and session management. So what's the main problem with HTTP? Stateless, okay? It doesn't contain the state. So what it means is every time you send a request and you receive a response, there is, like the application in a way needs to know that it's you who are submitting that request and that the application is sending back the response to you. So credentials, in a way, are kind of submitted back and forth. And, well, you could say, well, if we use SSL, everything should be fine, but that's not the case. If you use SSL, the only thing you're guaranteeing that you have a secure kind of connection between your browser and the server. But that doesn't guarantee that the actual, someone could get hold of your details. There are a few session management flaws. One is around the session ID. Like the session ID is used to track state. Like if there are a few developers here, they will know that session ID is sent back and forth. Once you are authenticated to an application, session ID is transferred back and forth between your browser and the application. So it keeps state. But if someone get that session ID and start using it like if, for example, I get someone's session ID and I start using it myself, it will be the same as the actual authenticated user, okay? And the problem with session IDs is that typically they're exposed on the network, browser, logs. So if you have access to pieces of the application, even if you don't have specific access to the credentials of the user, if you have access to that pieces of information, you will get your hands at that session ID. And there are these kind of side doors, and the side doors are interesting because I found plenty of side doors during my engagements. You could have an application that is completely secure, and that application you have SSL installed, and you put your credentials and the validation is performed correctly, and you have kind of the whole set of pages that you visit is HTTPS, except because someone management or the architect decided that, for example, the help page doesn't require SSL. So you click help, and as soon as you click help, it goes back, say, from an SSL state to a non-SSL state, and that session ID is disclosed, okay? And there are other cases that I'm going to talk later, but it's very easy to have side doors in your application. And well, obviously the typical impact is users' accounts compromised, okay? Or those session IDs I mentioned earlier hijacked. Typical example, you have, I don't want to kind of mention names here, but you could have you could have a session ID that is transferring, kind of that session ID back and forth between the application and the browser, and you have say URL rewritten. So the session is written in the URL. So you look at the session, and that kind of URL is showing your session ID. If someone, say, I am an attacker, and I kind of induce someone who is authenticated already in that application to visit my site, and that site, again, without mentioning names, I have a dodgy site. If that person clicks the link, I could look. If I am the owner of that site, I could look at the refer header. The refer header contains sensitive information about your session. So someone could get could get your session ID by just looking at that refer header. So how to avoid this? First off, you need to verify your architecture. You need to make sure that the authentication is simple, centralized, and standardized. Then you need to use a standard session ID provided by your container, and you need to make sure that this SSL protects not only the credentials, so not only when you are logging into an application, but also the session ID should be protected at all times, just to prevent those side doors I mentioned earlier. And also you need to verify the implementation. Like you could say, well, I run automated scans or tests and see how my application is performing, but just forget about that for a sec and try to think about the business logic of the application. So start to think like someone who is attempting to attack your application and think ways on how to, say, circumvent the security. It's a really good exercise, and kind of between development teams in the same organization, you could say try to promote that kind of activity. Check your SSL certificate. Well, this is quite obvious. You need to make sure that you have a valid SSL certificate and it's not, from a dodgy company who signed an agreement in your back with kind of someone else, and they are disclosing SSL certificates with third parties. You need to make sure that all kind of authentication related functions are properly implemented. That verify that logout functionality, the logout functionality destroy the session. And this is another example that it's quite common. You have an application, again, you have all the pages protected with SSL. It's kind of a strong kind of authentication mechanism. Everything is in place. You have, strong passwords, etc. And then you click, OK, log out. And the logout is, just a JavaScript code that will get rid of the session ID on the browser, but will not destroy the session ID in the server. So if someone gets, your session ID, he's almost waiting for that moment, because then he could use your session ID as well. And here I'm not even talking about concurrent sessions, because that's kind of a complete different league. Like if an application allows concurrent sessions, then you could have 2 or more users with the same session ID, interacting with the application, and that's really bad. Like you could have a user who is authenticated and doing financial transactions, and at the same time you have a user emptying that account, and the session ID is exactly the same. And I'm going to talk briefly about OWASP. Do you know what's a kind of a proxy, like a web proxy? Have you ever used a web proxy, or do you know OWASP or OWASP Web Scarab? Okay, well, those kind of tools are really helpful if you're a pen tester or if you want to test the security of your application. I'm going to show you in a sec how to use Web Scarab to just play with requests and responses between your browser and your application. So basically, it allows you to modify on-the-fly values and see how the application behaves. So how are you doing with time? Because I want to know if I could run 35 left. Have you ever seen WebGoat or Web Scarab? No? Okay, I will do a quick demo here. Okay, this is kind of the OWASP live CD. It's an ISO that you could download from the OWASP website, and it contains all different various tools that are available to the community. What I'm going to show you today is 2 tools that I regularly use for training. One is called WebGoat, and WebGoat is a kind of a dummy web app developed in Java that it's on purpose, vulnerable to a lot of the kind of the risk identified in the top 10. So you have problems with cross-site scripting, problems with SQL injection, problems with authentication, etc. So it's kind of an Apache server. You just start the server, you start the application, and then Web Scarab is kind of this intercepting proxy that I was talking about. So you have the main console for Web Scarab, and the proxy here, I will only intercept requests. So every time I try to do something with this WebGoat application, it will be intercepted first. So if I go back here and I click go to WebGoat, okay, it already started to intercept the request. So here I just accept the changes. Here I will put the credentials, which are very secure. And once I'm logged in, you have this environment, okay? And in here, you have plenty of exercises. One that I wanted to show you is this one. In here, you have, for example, you have this application, and I will just run it myself. Usually, I ask the students to do the exercise, but we're going to do this one together. So here you have kind of a login page that says, well, this is just to show you how a multi login works. This is the case where you have this kind of code cards that they will give, like the bank will give to you, and you have different codes for different transactions, etc. So I will assume I'm Jane. So I put my name here as Jane, and the password is *sun. Okay, we're very inventive with the names here, and like here I have my 6 kind of TAN or unique codes. Okay, that each time I use one of these, it will expire. Okay, so I shouldn't be able, in theory, I shouldn't be able to use it again. So I click submit. And I managed to type it wrong. Okay, and here it's asking me for TAN number 1. So just copy 15648. Type it in. I know you realize something that here, one of the variables is hidden TAN, and the number is 1. That will come helpfully in just a sec, okay? So stage 1 is complete, and we are logged in, and we are Jane, and we are checking our balances, etc. So if I am a hacker, okay, and I stole some information from Jane through a phishing mail, or through a kind of a malicious way, I obtained some sensitive details, and I know that the password is *sun and the TAN number 1 is 15648. In theory, if I'm a hacker, and I try to say, I know Jane sits beside me, so I kind of, over the shoulder, I look at her credentials, and I know her password as well. I'm presented with a problem here. Okay, it's asking me for TAN number 2. In theory, I don't know TAN number 2. Effectively, I don't know TAN number 2. Okay, so what can I do about it? Okay, any ideas? Or I do it myself? Yeah. Yeah, very good. Yeah, so it doesn't matter what you type here. I could type 1, 2, 3. Doesn't matter. As soon as I look at this, I just change the value. And I know the TAN value number 1, okay? So I managed to log in as Jane. And this is happening because, like on the client side, the kind of the validation is performed that you shouldn't be using the same TAN over and over again. But on the server side, nothing is kind of invalidating that previous time, okay? There are plenty of exercises. I will try to do one or two later on if time allows, because usually with the top 10 I run out of time. So I will try to keep it short. But like if you want to play with kind of the top 10 vulnerabilities, or you want to familiarize yourself and try to act as a malicious user, and you know, try to break an application, WebGo is great because it will allow you to kind of play effectively with a vulnerable application. So then the next one is insecure direct object reference. And it's tightly related with the other risk called failure to restrict URL access. It's all around the authorization. And what it means is you usually have a list of authorized objects for the current user, and then all the rest is hidden. He will never discover that. You know, it's like we only make visible the options to the user based on his profile, and the rest we don't protect it. We don't protect those functions, but he will never be able to you know, discover them. That's wrong, because there are crawlers and there are tools that will allow you to discover all the different functionalities in a website. It's called presentation layer access control, or security by obscurity, as some of the people call it. Like, it's really bad. So, like, the typical impact here is that the user will be able to access unauthorized files or data. Another example here is when you have, I don't know if you ever tried this, but like someone with kind of this mind of, you know, looking at ways in kind of looking at things in different way. You will probably be tempted to say, if you have you access to a website and you look that your account is this number, like some people will go and change it to a different account number and see what happens. Sometimes, or most of the times, it will not work. Unfortunately, some of the times it works, and you have access to, you know, user details and you know, sensitive information that they shouldn't have access to. And the same goes for the functionality of the website. So sometimes you are able to access functionality that's only for admins, but it's only changing a parameter from false to true, and it will allow you to do stuff that you shouldn't be able to. How to solve this, or how to prevent it? You could eliminate that direct object reference. You could use a sort of a matrix or a mapping where you could use, for example, ISAPI, that will transform a URL like this into something like this. Okay? So you are not disclosing the location and the exact name of the file, and you are able to also restrict those values. You could say, well, this user will have access to files from number 1 to number 10, and like the rest of the values are not accessible. And the same goes for the IDs or the account numbers. You could have account numbers, instead of having the account number display in the URL, you could have a random, you know, random value that will not explicitly identify who's that user. So different ways of protecting insecure direct objects. Then you have cross-site request forgery. Have you heard of cross-site request forgery? Okay, very good. It is a bit tricky, and like when I kind of presented this talk, I presented this talk a few times. This kind of cross-site scripting cross-site request forgery was kind of, well, it shouldn't be that troublesome. It is very complex, but the thing is, like as time goes by, you become to realize that it's quite easy to have this kind of problems in an application, and kind of the way it represents itself is an attacker will be able to perform actions on behalf of an authenticated user, and this how like you wonder how this could happen. Well, you have browsers that will automatically include user authentication data, okay? Session ID, IP address, Windows domain credentials. This is typical of intranet applications that you have Windows, Windows credentials flying all over the place with each request. So if I have a user who is able to kind of trick me into doing something by ways of visiting a URL or clicking a link, it's the same as if the hacker or that user is steering your mouse and getting to click on different links in your online banking application, and you don't need to imagine what they're going to do if they have access to that, right? The typical impact is, well, obviously initiate transactions, access sensitive data, and change the account details. I think I have an example here that it will be much better than this one. Let me see. Yeah, I will try to do a quick demo about this because it's much easier to explain it. So there is a specific example of cross-site request forgery in WebGoat. And well, okay, here you have, okay, my idea is to, well, send an email to a news group, and that will contain an image that the URL will point to a malicious request, okay? So what I'm going to do is try to include a 1-by-1 pixel image that will actually contain kind of an HTTP request that the user will execute unknowingly. So just to save time, I will look at the solution. You shouldn't be doing this, but I'm going to do it for the sake of time. So you have, for example, I will grab this. You know how to say have an image represented in HTML, okay? It's image source, and then you have the URL, blah, 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 and then you have the width and the height and like, etc. What we're going to do is to create a payload. I know that the application has the application has a parameter called transfer funds, and what I'm going to do is I will make a kind of an invisible image. An invisible image that will call that call the URL to make a transfer, and I specify there the values. Or so I want to transfer 5,000 euros, and I will submit this to a forum. Okay. So here is saying board.ie, or a forum site. You have this link. You look at the link, and the link, if you actually look at the what's happening here, you will not be able to see anything here. Like the screen doesn't allow to show you the entire URL, but in here, like I'm just putting my mouse over that link, and if I look at this, it will not say anything about transfer funds. Okay. And even if I click it, and I look it I look it into the kind of WebScarab interface, I don't see anything happening here. So if I click accept changes, but something happened here. because while I was, while the application was parsing the page and showing me the content, it found another request, and that request is to transfer the funds. So I'm able to capture this in because I have a proxy, but for a normal user, that user will never see this happening, and he's actually, or that person is effectively performing a transfer of funds. So how to avoid this? There are there are various libraries that they are called anti-cross-site scripting, and basically, without going into all this detail, there are like the trick to prevent this is, imagine you have the same URL I shown you. If you have a random token each time, someone is trying to execute that, like it is a way of validating the request. If there is a random token generated by the application and that token is missing, then that request should never happen, okay? Or it will be, rejected by the application because the anti-cross-site scripting, cross-site request forgery token is missing, so that request will be invalidated. Security misconfiguration is basically all around secure, like server hardening, and applying all patches and antivirus, etc. But you also need to kind of take consideration around the development environment. Usually, like the business will say, well, we have the production environment fully protected, but sometimes they forget about what happens in the development environment or the testing environment, and they don't have the same measures. So it's something to really consider. And like if your source code is a secret and you have development teams working with your code and you never ask them for an NDA or you're not protecting the code, it is mandatory that you have kind of server hardening in place. And well, the credentials should change in production. That's a no-brainer. And well, there are various things that could happen, like backdoors, cross-site scripting flaws due to missing application patches and unauthorized access to default accounts. Very brief example. You have it's basically someone who say it's an insider. I have access to all these different layers. It has access to the operating system, web application server, the application server, etc. And how to avoid this? Well, as I said before, follow security hardening guidelines. It needs to cover not only the platform, so not only the operating system, but also the application layer as well. Keep up with patches and then try to kind of keep a record of the current configuration of your environment. Failure to restrict URL access. This is related to the indirect reference, and like the idea here is again to protect or to enforce proper authorization. This is what I was talking about earlier, displaying only authorized links and menu choices. Like the typical impact is the attackers will invoke functions and services they are not authorized for, or perform privileged actions. I will show you a brief demo. So here you have the guest user has access to the different kind of pages, the kind of help pages in a web application. and kind of there are different pages here that will display. If I click view file, I will be able to look at, the contents of that file. But if you look more closely at kind of the full path of where these files are located, you could see here that, okay, this file is located here, okay? So OPT, OWASP, WebGoat, Tomcat, Web Apps, blah, blah, blah. Our plan, or what we are trying to achieve, is get our hands at a sensitive file that is called Tomcat conf Tomcat users.xml, and that file will actually kind of display all the users for that Tomcat server. Okay. So, any ideas how can I achieve this? Do you see a kind of a pattern here between the two URLs, or kind of do you see a way of trying to get to that file? Okay, and where do I put it? Okay, so in here. And what do I do here? Very good. You've done this before, huh? Okay, so from here, what we are actually doing is directory traversing, and we are going up. Okay, so we are here, and by doing this // we are going up. Okay, so we're going up 3 times. So lessons plans, WebGoat, Web Apps, and now what we need to do is take this. Okay, so now we are kind of going down. So we get rid of this. We don't need this anymore. And we need to get rid of this as well. So you see what's happening there? I'm actually going 3 steps up and then going down and trying to get that Tomcat users. And I'm able to see that Tomcat users.xml, okay? Thanks there for the lesson. So going back to the slides, well, I think I covered this with the example there with WebGoat. How to avoid this? Well, you basically need to do 3 things: restrict access to authenticated users if that URL is not public. Then try to enforce any user role-based permission if that URL is private. So if I'm trying to access Tomcat user.xml and I'm the guest user, I should never have access to that file. And try to completely disallow requests to unauthorized page types. And this is very common to find, like that you have, for example, in the development environment or the testing environment, like people left their, the leftovers of, configuration files or manuals or user guides, and then they just click push to production, and they push all to production. They don't get rid of those configuration files, and those files contain sensitive information about your application. So you need to make sure that you only allow people to access the files they require for their kind of their job, and that's it. Unvalidated redirects and forwards. Are you familiar with the term redirect and forward? Entertainment.ie, for example, use redirect. like you're visiting the website and you look at the website and you say, well, I would like to go and see this show, and you just click a link and it will redirect you to a different site. Okay? Entertainment.ie, they're doing it properly, and they are, displaying the information. They're actually saying to you, you are leaving our site and you're going to a third-party site. But imagine if Entertainment.ie, they don't do that. They just redirect you to a random site. And I'm a malicious user. And I use the same format of that request, and instead of sending it to the Gaiety theater, I send it to the hacker theater, and I send it to a completely different page. Like the request, if you look at the request, if you receive an email and you look at you could actually look at the URL, it will say that the beginning of the URL will say, well, this is from entertainment.ie, so it will look valid. But the rest of the URL will contain, a malicious redirect. So you should be able to you should prevent those kind of invalid redirects. And forwards is the same. They call transfer in .NET, and it's kind of these transfers of pages from page to page inside an application. They are usually done internally in the code. But you need to be careful with those forwards as well. So, typical example, and I actually explained it already. You have the IRS, well, this is from the States, but the idea is that you have a URL that will allow you to do something like this. You will have a parameter that will allow you to redirect someone to a different site. And if you are doing this in your application, you should inform the user that is leaving your site, and like you're taking him to a different place, and it's outside your web application. Well, how to, or best practice here, try to avoid using those kind of redirects and forwards as much as you can. Like if you need to use them, well, at least try to use them and define parameters like you could have, for example, a mix of, I talk about access reference maps, or those maps that you could implement, the matrix that you could implement with this API. So you could say, well, I will only allow this user to go from, the destination URL will be a value from 1 to 10. If someone tries to put a URL, it will not go anywhere. And I control the values between 1 and 10. So 1 and 10 are valid, and if someone tries to put 11, it will not work. And well, same theory applies to the forwards. Then almost reaching the end here. Are we going okay with time? Well, the kind of the other kind of risk is in relation to insecure cryptographic storage, and this is quite basic, but so many times people implemented it wrong. They just say, well, we have SSL, that's it, end of story, we are secure. There is no problem with my application. There are different things that people don't consider, and well, like here it's kind of merely kind of a list of things that you need to take into consideration. But for example, you need to identify where your sensitive data is located. Surprisingly, you will find that some companies, they don't know where the sensitive data is. You ask where is all the sensitive data, and they don't even have a DFD or a map of their application and how it works and where all the sensitive bits are stored. Then you need to protect that information in every location. So if you have a table that contains financial details, well, first off, PCI will go after you. If you are storing credit card details, like you need to make sure that those details are encrypted, that you are not storing more information than required. So you shouldn't be storing the CVV or the CVC2 value. Like you need to consider a lot of things. In this regard, the Data Protection Commissioner here helps a lot. So if you are involved in in the development of a sensitive application and you don't know what things you need to consider to encrypt, they will tell you. They are very open, and you could call them, and then they will give you guidelines on how to protect the sensitive information, or what kind of pieces of information you need to protect. And well, typical impact for this, it's very basic. You will have malicious user accessing sensitive data, and you don't want that. So, for example, the victim entered credit card number in a form. Could be not the credit card, but could be, I know, her personal details, address, or pieces of information that they will be considered sensitive. And you have your database encrypted, so that's happy days. You have that information encrypted, but unfortunately for this girl here, there was a problem at the time when they were they were in downtime, and the database was not available, so there was an error. And that error, well, the error was logged, because again, should be logged. But the problem is the way they log that information. They actually include the credit card number in the log file. Okay, obviously, log files are accessible to IT because they need to troubleshoot issues, and suddenly you have, a malicious insider or someone with access to that information that, first off, will be a big discredit for the company, because it will be a big hit. Also, there is going to be a problem with your with the regulator, and you will have they will bark at you and tell you you shouldn't be done this, and they even could put you fines if they find you in breach. But basically, what happens here is you have an application that it is more or less it's mostly secure, but because of a very basic error, you're disclosing sensitive information. How to avoid this? Well, again, verify your architecture. Make sure you know where all the sensitive data is stored, where it's transferred, how it is transferred. You will have, applications that they transfer sensitive files from one place to the other, or you have different applications that they talk to each other. You need to make sure that they are actually talking between themselves in a secure fashion. And finally, it's the last one of the top 10 is the insufficient transport layer protection. This means how we transfer data from one place to the other, and how secure we are transferring, how securely we are transferring that information. So again, it goes back to the point before. You need to identify where all that sensitive data is located. So when you're transferring it, you make sure that the data is protected in transit. You need to consider, well, the web application, backend databases, business partners. Sometimes you have business partners that the partners will connect through FTPS, but then you have access to sensitive information in the clear. And the typical access, or the typical impact is, again, access to sensitive information, okay? And there are two types of threats here. One is called the external attacker, who is, sniffing what's happening between an external user of your application. It could be a DM seed, an application that is external facing, and someone could be looking at the traffic there, but also could be an internal attacker. So you need to consider both sides of the coin. How to avoid this? Well, try to use TLS, or the kind of a secure transfer mechanism. For XML, there are kind of libraries that will help you. For example, XML encryption and XML signature, and try to use those mechanisms kind of in a correct way. Again, there are cheat sheets for this as well. There are actually cheat sheets for each one of those, like all the different kind of risks that I presented today. There is a cheat sheet associated. So, as a summary, how do you address how to address all these problems? Well, first off, you need to start developing secure code. So if you are involved in coding, there is plenty of material available. There are guides and kind of different tools and processes available at OWASP that you could use. The application security verification standard, it's kind of a spreadsheet. I'm not going to kind of explain it in detail here, but it's kind of a spreadsheet that will tell you kind of, it will help you to establish a level of rigor in your web application. So based on the criticality of your application, you could, enforce stricter controls. ISAPI, I mentioned ISAPI. It's very good, and it's very kind of tight with ASVS. So based, for example, in the level of rigor that you establish for your application, you could use ISAPI to enforce that level of rigor. And then review your applications. You could build up an expert team, or cross-train different teams in your organization. So that will kind of help to, like the different teams will learn on how to test applications, which is very good. The experience I had with kind of previous employers and kind of the different people I was involved in these exercises was kind of very good. And like then there you have the code review guide and the testing guide, which again, one is it will help you to kind of review this code, kind of how to look at code in a way of an attacker, and how to look at it, and then the testing guide on how to perform all these different tests, say with different pen testing tools. Last but not least, we're having this conference in September. Like usually we bring people from all over the world. It's very good. Last year we had more than 300 attendees. This year it's from September 4 to 6 at Trinity College. Training and presentation opportunities are available. So if you want to present there, you're more than welcome. And if you want some more info, that's the URL. And that's me. Have I done quite okay with time? I'm going to be around later on, so yeah, that's fine. So you could ask me questions later on. So again, thanks for having me, and I hope you enjoy this presentation.
Okay, guys. So to try and get out here somewhere around 8:30. Let's keep moving on. So next up is Martin Mitchell, who's going to tell us how to use all the tools that Fabio was talking about in an ethical manner. So over to you there, Martin.
Can everyone hear me now? Yep. Okay, my name's Martin Mitchell. I've been asked today to come and speak a little bit about ethical hacking. So firstly, who has heard of ethical hacking before? Hands up. Participation. Okay, so who's a dev? Sysadmin? Who actually works in a hacking type, or who actually works in a security or ethical hacking role? Okay, cool. So firstly, I am an ethical hacker. My day-to-day is mainly web apps. Before I started working in web app security about 2 years ago, I was mainly kind of around the wireless kind of side of things. I'm one of the founding members of the TUG hackerspace based in Dublin. If anyone's ever heard of a hackerspace, come visit them, support them, great. I'm also a 2600 member. 2600 is probably the main thing that got me into hacking and into the ethical side of hacking as well. 2600, if no one's ever heard of it, it's a magazine that's out every quarter. It's been going since 1984, so it's been around for a good while. And what's happened is, because people were interested in the topic and interested in the magazine, cities started to organise monthly meetups and just meet up, talk about security and just shoot the breeze and have a beer. And there's actually one in Dublin, and there's some more starting up around Ireland as well. I'm also an OWASP member. I don't think that was known before I was asked to come, but I've been an active OWASP member for the last 2 years, and I do use all the information and all the tools that Fabio was talking about just there. And another thing is, I attend conferences. So I don't just sit at home, I don't just go to work and work on the kind of security stuff. I go to the security conference that are on, because you do get to speak to a lot of very, very interesting people that normally you may think are not approachable through email and through other sorts of contact. But if you actually go to the conferences, you actually meet these people, you can walk up to them, you can buy them a beer. Beer is always good when you want to try and talk to people. So what we're going to cover today is, what is ethical hacking? So for people who may kind of just have heard the term lately and may not exactly know what ethical hacking is, we'll touch on that. What is a hacker? A lot of people kind of have a misconception of what a hacker is. Why hack ethically? That's always a good one. How to learn. So OWASP was always a great one to start with, but there's also other ways that you can learn how to do this. And then I was going to do questions, but since we're short on time, I'm sure we can take the questions in the bar afterwards. So firstly, it's not like in the films. You don't stand up in front of 9 monitors, have a gun pointed at your head while you're asked to break into something. Films and media do make hacking very, very sexy, because you press a few buttons and then you get into a bank, or you press a few buttons and some servers shut down and you hack the Gibson and you ride around your roller skates. Really, it's not like that. I don't even think I own a pair of roller skates. So ethical hacking is hacking ethically. So it's to be able to use the skills that you know about being able to penetration test either networks or web applications, but you know when to stop. You find issues in products. So a lot of people who are hired as ethical hackers will be hired either by companies or by companies who actually own the products, or they'll be hired by consultants who are hired out to companies like banks or other sorts of institutions who will actually perform the tests on their products. So they're outside of that, outside of being employed as an ethical hacker, you could also do it as part of a research role. So masters and final year projects are always to have like some sort of an ethical hacking or security type topic on your project. It's always good. Next thing is, generally when you're ethically hacking, you have permission to do so. So it could be like an open source project where you have full access to the source code, and you may notice that, okay, there's like some sort of an issue here when you pass in credentials, they're not being checked for, let's say, some SQL injections. And then another thing for ethical hacking is competition. So has anyone heard of CTF before? So if anyone hasn't heard of a CTF, CTF is a capture the flag competition. So similar to where you play it like Halo or some sort of Half-Life or anything like that, there are numerous competitions on every year. I think it's upwards of about 15 or 20 competitions throughout the year that are capture the flag competitions. So each team enters. They are given a server to protect. So it's going to run a number of services. So it could be network, it could be web app, it could be actually just applications that are running on a server. And it's your job to protect your server. So that's one type. Another type is there's a website put up. So similar to WebGoat that was actually explained today. There's a website that's put up, and there's a set amount of time. So you could have 24 hours, you could have 12 hours, and it's your team's job to try and access as much of the application as possible. Now it's set up in an insecure way. The further you get into the vulnerable application, you actually collect tokens, and you collect the tokens, submit them. Competition, a lot of fun. If you've never tried this capture the flags are a lot of fun. There is one that's run in Dublin in November called Hackera. That's part of the Irish conference. A lot of fun. Next is, what is a hacker? So, in the greater scheme of it, a hacker is somebody who has a pursuit for knowledge, who really just wants to know more about technology, know more about computers, know more about IT. And they also have a good respect for the skills that other hackers will have. Definitely a motivation for self-teach, because when you're studying hacking or studying ethical hacking, it's not quick. You can't just read a single book and say, okay, I can hack I can hack web applications. You have to spend a long, long time because there's many, many different ways to both attack and protect against attacks on applications and things like that. Next is the sharing of information. It's always a big thing as well. So, like OWASP, they share all the information quite freely, and there's docs and books all down available for free. And next is a challenge. It's a lot of fun. So rather than sitting there, you're developing a web application for 6 months, gets released, you get handed the next application, and you got to work on that. Some people like that. I don't. I tried that for a while. What I actually like doing is I like getting my hands on code. So let's say in work, I get my hands on code. It's my job to try and see if I can break the application. And if I can, I report the defect. They try and fix it, give it back to me. Sometimes it's not fixed. I break it again. So there's a good bit of fun in that. So when we're talking about hacking, there's two different hats when it comes to hacking. There's your white hat and your black hat. So white hat is a guy who has all the ethics. He's the guy who will look at something. He'll know he's kind of gone to a certain point, and he'll stop and he'll disclose. So for vulnerability disclosures, what happens is you contact the vendor. So let's say Google. There's a vulnerability in Google in Mail, so that I can log in as another user. I will contact Google and I will tell them the problem. I will tell them what's wrong, and so that's me ethically disclosing the vulnerability to the vendor. It happens on both open source and closed source applications. Open source is a little bit easier because at least then if I find an issue, I can download the source code, I can investigate the source code, I can see what the issue is. I can sometimes fix it and actually just apply the patch, especially if it's a GNU project. Closed source is a little bit more difficult because I don't have access to the source code. Sometimes I have to reverse engineer. So if anyone's ever heard of reverse engineering, it's where you get an executable file and you have to decompile it, and you actually go down to machine code, and some of the decompilers will actually spit it back out as C code or some other type of source code, but it's not exactly nice to read. So you really have to have a good understanding when you're trying to do some reverse engineering. So an advanced understanding is definitely required for when you're a white hat, because you need to kind of think more about what the application is actually doing rather than what it could be doing. And you're working to protect. So you're working to make sure that a web application is secure. You're working to protect that that your Android mobile phone application, that your Android application is, your OS is secure. So white hat is a hacker. So they do use the exact same kind of methods, the exact same attacks on applications, but they know when to stop. So ethics is another thing there. So black hats. Black hats kind of more going towards the break it. A lot more lately, black hats are kind of moving more towards, like 10 years ago, let's say, black hat would do it for fun. They kind of break into a web server, they'll say, great, broke into it, they just leave it be. They probably wouldn't do anything. They just did it to prove something to themselves. Some black hats actually still do that, but a lot more black hats are kind of moving more towards profit, because crime and gangs now have moved a lot online because they realize that some of the highly skilled black hats can get access to databases which contain credit card information, which contain user information, passwords, email addresses. And all this is worth a lot of money on the black market. So then, if they get access to a database, they can start to sell it, they can start to make money. They also disclose vulnerabilities, but it's more along the lines of, if a white hat was to disclose a vulnerability, they'd actually give the likes of Google a certain amount of time to try and fix it before they'd report it. So they'd give Google, let's say, 3 months' time. So they'll say, look, I found this vulnerability, you've got 3 months to fix it, and then I go public with it. So there's generally patches put out before that. So what black hats tend to do is they'll actually just throw it out on mailing lists, they'll throw it up on websites. They'll do it more to actually hurt the company itself. Also, a lot of black hats are kind of moved into the virus and malware scene as well. So, credit cards. So for viruses and malware, it's about getting your virus and malware onto as many machines as possible, because nowadays botnets are worth a lot of money as well. Because if you have the power of 10,000, 100,000 machines, it's quite valuable because you can use it for sending spam. If you want to shut down a website for the day, so let's say you want to shut down MasterCard, Visa, PayPal, they've all been shut down by botnets. So what happens is somebody decides that they want to take their botnet, could be 10,000, could be 100,000 users. They tell all the botnets to send 2,000 requests per second to this website, and the website is no longer accessible by legitimate users. That's called a denial of service attack. And the fact that it's done by a botnet, it's distributed, so it's called a distributed denial of service attack. And it's illegal. Just thought I'd touch on that. Gonna have to. So next is script kiddies. So script kiddies are kind of the guys that they're enthusiastic about hacking. They've probably read a few books. They've probably seen a few films. It's like Joey here. Does anyone remember where Joey's from? Yep. Cool. So so these guys are they're kind of like shoot first. They kind of like, they see that they want to do something cool. They kind of want to break it, but they really don't realize what happens when they do break it. So it's kind of more along the lines of they'll download a tool, they'll point it at a website like Google, they'll hit the big go button, and then they'll see that their friends can no longer access Google. So they're like, yeah, cool, I did that. They'll start bragging to their friends, they'll go onto chat rooms. So they're kind of naive. They actually don't really understand exactly what's happening. As far as they're concerned, they've pointed their application at a website, they've hit the big go button, and the website's down. They don't realize that on the other side of it, the website's losing money. Also, that they're leaving breadcrumbs all over the internet, because when you access a web page, it's not just a direct connection from your laptop to where you're trying to access. You're bouncing through a lot of servers, and it's quite easy for, let's say, somebody who is quite skilled and has the resources to try and track you down. They can do so. The last bit there is profit, because what can happen is you can have a black hat who has a lot of credit cards and wants to be able to sell it on, but he doesn't really want to try and sell it all himself. So if he can talk to somebody who would be hanging out on forums, kind of naive, like easily led, they can get this person to sell it on their behalf and just give them like 100 quid or something. They're happy because they're making money, and the black hat is really, really happy because he's kind of proxied his transaction. Next is hacktivism. So more from the script kiddie kind of side, you would have people who are on an online forum, and they would be kind of saying, oh yeah, it's really bad that like WikiLeaks is trying to be shut down and stuff. And then all of a sudden, they're just told, okay, if you download this application and you point it at paypal.com and hit the big go button, all of a sudden, hacktivists have a denial of service attack, which are people actually running it themselves. And a lot of the time, they really don't understand exactly what they're doing. They just think it's kind of cool. They're doing it for the bragging rights. If anyone doesn't know this image, this is the image. This is one of the SOPA protests in Dublin. They were they kind of cared less about the fact that the internet censorship, and just wanted to make sure that they could access their pornography. So next is, I'll just highlight that you may think you're being smart when you're accessing the internet by trying to cover your tracks and taking part in all these attacks, because you may think you're like, so here's an example with Sabu. He used to take part in the LulzSec. I'm going to assume most people know what LulzSec is. He used to take part in some of the organization for some of the LulzSec attacks. And the way that he kind of hid himself was that he'd use Tor and anonymized in proxy. So what happened is he'd go through the proxies, packets would be bounced around the internet, and then it would pop out somewhere, so his actual location would be hidden. Subu forgot to turn on his Tor once, and there happened to be someone monitoring the chat room. And from that, they were able to get his home IP address, and then they were able to get access to him and do that. So next is why hack ethically. Firstly, when you're hired as an ethical hacker, your main job is to protect the company name. So whether you're hired as a consultant or you're hired directly for a company, the main objective is to protect the company name by making sure that the company that you're working for, or the source code or the product that you're looking at, isn't going to be released that is vulnerable. And that in turn will protect assets, so you don't want servers getting taken over, and customers' information. So by hacking ethically, you're also stopping the bad guys. So you're actually finding these bugs and you're patching these bugs before the bad guys actually get hold of these services before they're actually released. It is fun, it is exciting. Now, some days you could be working on something for like 2 or 3 days and not get anywhere. And you can sometimes work on 2 or 3 days and actually achieve your goal. So it is always a very good challenge. And then there's how to learn. So practice, practice, practice is definitely one thing that you should do. There's loads of resources out there. Capture the Flags are a really, really good resource. You can download vulnerable operating systems like damn vulnerable web apps, damn vulnerable Linux, WebGoat. There's also a few more if you just go on Google. Next thing is ask. Don't be afraid to send someone an email and ask if you're unsure. Like if you're trying to like complete a level, don't just like throw it away. Kind of ask. Like there's always forums and mailing lists for you to ask about certain things. Next is understand. So if you're not a developer and you want to try and get into web application security, maybe learn how to code as well, because it's one thing to know that if you put in an extra quote in a search box and all of a sudden you see an SQL error, that's one thing. But if you actually, it's really good to try and understand exactly what's going on as well. Then there's research, so plenty of reading. And then also is attend. So you attend conferences, you attend meetings. Also good as well. Next is, has anyone got any questions? How fast was that? Has anyone got any questions on that? Sorry? There's loads of certifications. There's ones like the Certified Ethical Hacker, which is a good one. The only issue with most of these certifications is like whether you're going from, let's say, a Certified Ethical Hacking point of view, or even for networking things, you kind of have to renew these all the time. A lot of the time, you really don't need to. Learning all this stuff on your own is good enough. Some employers will actually require you to have some of the certification. Certified Ethical Hacker is also a good one. Masters is a good one, because especially if you do a master's, you can go and do your own research in your own area. Also shows a good bit of work as well. I don't know, the Certified Ethical Council, or the CE Council. Does anyone know who stands behind the Certified Ethical Hacker? It's approved by certain companies. Certain companies actually like their employees to have it. But there's also ones like the CISSP, which is probably more of a one that you'd go for when you're in the industry for a number of years. I think you need to be in the IT security industry for about 4 or 5 years before you'll be allowed to take that exam. Yeah. There's no real way to say an application is completely secure, because there's always new vulnerabilities out. So it could be a vulnerability out for either the web server it's running on, or for PHP that it's been written in. And also you don't know whether, and also the SQL data, and also the database it's actually talking to as well. So there's always a lot of elements that could lead to that could also lead to a application which was once secure that could become vulnerable. There's also then, you need to make sure that there's also the user as well, because you could have a really, really secure application and you could have a user that picks a really, really crappy password, or picks the exact same password for their Facebook and Gmail, and then uses it on some dating website, and the dating website gets hacked. And then all of a sudden their Gmail address is being used, their username, across multiple accounts, and it's the same password as well. Yeah. Yeah. Right. But I've also heard of a couple of PCI DSS websites or companies get hacked as well. Yeah. Yeah. Or at least you can say, well, well, we've tested for the OWASP top 10 as well. So rather than say, I looked at it and it didn't really break when I had to go with it, so I think it's secure, but... Anyone else? Or will we wrap it up and go to the pub?
CEH is from the EC Council, and it is quite technical. There are also some good certs, technical certs, provided by SANS. I don't know if you ever heard about it, but those are kind of top class. If you want to get into the technical stuff, they offer kind of different kind of grades, and you could kind of improve yourself and get kind of higher and higher certifications. So it's actually getting a path on how you become certified. And also IAC Square offers one that is recently, and it's related to application security, called the CSSLP, that it's kind of a mix between business and technology. So there is a kind of a mix between. It all depends on what kind of certification, or what's your goal. If you're, say, more towards technology, I will highly recommend, for example, the SANS. And if you're more into the business, I will go towards, kind of IAC Square and kind of those kind of certifications. So I hope that clears a bit more. And actually, I don't have anything else to say. Do you want to talk about Google Summer of Code, or do we leave that? Yeah, no, you say something about it. Well, have you heard of Google Summer of Code? Yeah. Well, this year, 1 minute. I will make it in 1 minute, in 30 seconds. Always this year, like Google Summer of Code, it's kind of a global initiative. It's great, and it involves students all around kind of the world to code and improve open source projects. OWASP, as an open source organization, applied, and we were accepted this year. So among kind of, there are 180 organizations that are kind of endorsed by Google, and they are participants in Google Summer of Code. The deadlines are a bit tight at the moment, because right now the student application process started and will run until the 6th of April. But there are, I think, between 8 and 10 projects in OWASP that you could contribute. So if you're a coder, or you're a student and you want to get more familiar with coding and open source projects, I would highly recommend it. Just search OWASP, GSOC, Google Summer of Code, and you will find all that information. So with that, I'm finished here. I don't know if you want to have some final remarks.
Just a couple of things I want to go through. The usual notices at the end. I'll keep this brief because we're running late as usual. Google I/O 2012 tickets went on sale today, and they sold straight away as usual. I was on Owen there earlier. We may be running an I/O extended event. It's probably likely. One of the issues is that there is the live streaming part for Google I/O, so you can watch it at home. So whether you watch it here or watch it at home, there was a bit of a question over what's the incentive for people to come down here to watch it. So we were thinking of actually doing it. It's on, I think, a Wednesday, Thursday, Friday. We were thinking of actually doing it, which is the last Wednesday of the month. So instead of doing the last Tuesday of the month, switch it for June to the last Wednesday of the month. But anyway, we'll let you know the details as we kind of figure them out. These were just two things on the notices for last time. So, Startup Again Dublin was on actually here in this room. It was a really good event. Actually, you might have seen some stuff on the media about it. AppScript Hackathon that went on. We're waiting on a blog post to go up on that. Nicola did a great job. He's going to circulate the content, the slide content that he had, which is really powerful technology, really cool. Some other things that I just saw. Richard Rogers is doing the JavaScript tech disruption on Thursday in T-Cube. There's a WordPress meetup on the same time. There's a JavaScript meetup on April the 3rd. That was the Google Summer Code deadline, which Fabio has just gone over there. Next events, next one's all about social. So we're getting some Facebook dev relations guys to come on and do a longer talk. And then Fergal Reid is a guy in UCD. is going to talk about some social graph analysis stuff that they're doing, which is, very kind of socially oriented research, let's say. Tuesday, May 29th, last Tuesday, May. We're not really sure. We were thinking of last year we had a student focus session where we got undergrad students who were finishing up their final year projects just to come in and tell us, give a short presentation to what they were doing. I think that worked reasonably well. Put out a shout on the mailing list, probably see if there's interest in doing that again this year. We're still looking at organising a cloud focus event. We did talk about that a while back and it's kind of slipped off the agenda, but we're still in the back of our mind, so we're kind of talking about how to pull that together. That's basically it. Return your badges because the Google guys want to hang on to them. And then we're going to go for a drink in the schoolhouse. Most of you probably know where that is at this stage. So we're going to head down there in a couple of minutes, and then Dublin.GTUG.org is where you can find the information. So that's it for this month, guys. So hopefully I'll see you in the pub for a pint or next month. Cheerio.